Here's what we're going to do. You've all got different rectangles, but I want us all to be able to compare them in some way. Okay? So let's say that the square you started off with, let's say that square had side length 1. Okay, let's say for everyone, no matter how big your diagram is, let's call that side length, the square, 1. Okay. Now, therefore, let's just walk through how we constructed this thing. Okay? What was the first point I asked you to put on there? It was this midpoint, right? So that immediately tells you if this is 1, then this little distance down here should be a half, right? No problems. Okay, good. Alright, well now you've got a half there. How can I progress to work out the ratio between this side from the square to this new rectangle that I built? Can you see how I'm going to get there? The people who did it by ruler might actually see it a little more clearly than people who did it by compass, even though the compass diagrams would be a little clearer, right? How am I going to get there? I want this distance, right? That's where I'm going to go. Where do you suggest I go next?
Find the length of the midpoint to the corner. That's the radius.
Find the length of the midpoint to the corner. Good. Okay, so I'm after our hypotenuse here, right? How am I going to do it? Pythagoras. Okay, so this is 1 because it's the square. Okay, so you do your Pythagoras in here. Let's just quickly do it. Okay, square of a good. Let's just do the numbers. The square of a hypotenuse, right, is not plus, is the sum of the squares of the other two sides, like so. Okay, so on this I'm getting 1 plus a quarter. That's 5 quarters. Okay, so there you go. You get your hypotenuse by taking the positive because what I'm interested in are lengths, so that's why you don't have to worry about the negative square root. Okay? Excellent. So now we have this distance that got mentioned before, right? The square root of 5 on 2. There it is, right? But what did we do with this length? We brought it down over here, didn't we? These are radii of this larger circle, the whole thing I haven't drawn, but you've got the arc there, right? So therefore, this distance, let's see, where shall I write it? I'll put this half over here now. It's the same. This distance is here. That's the radius, right? That's my square root of 5 over 2. Okay. So what are the ratios of the sides? The ratio. This side is just 1. It's 1. So it's 1, 2, whatever this number is. Well, the whole length there, right? Because they're both on denominator 2, I just say, well, 1 plus root 5 on 2. Okay? Now you've got calculators there, right? What's that number? What's that number? 1 plus square root of 5. Careful with your brackets. What do you get? If I let's do 3 decimal places. That's usually how far they go. I think you should get 1.618. 1.618. Now this number is so important. This ratio here is the golden ratio. This rectangle we've drawn is the golden rectangle. Okay. This number, because it comes up so many times, we give it a name. We call it 5. There you go. You know you've made it if you're a number and you get given a Greek letter as a name. Cool, I'm important, right? So, phi, right, that's this 1.618 number there. Now it comes up all over the place. In fact, it doesn't just come up in geometry. I'll show you, by the way, if you were to draw the Great Pyramid and look at it side on. Look at it side on. If I went here and formed a triangle here, if this was 1, this would be 5 over there, the hypotenuse. Okay, so I know you're like, there are no rectangles there. I know, but the golden ratio is in there nonetheless. Okay, it's quite astonishing actually. It's not just in big things. It's not just in big things. In fact, if you get out your wallets, I can almost certainly guarantee, get your wallets out, that you will have a golden rectangle on you. Get your wallet out. Get your wallet out. Now, let's see, which one should I choose? Let's get out something innocuous. I've got a Flybuys card here, okay? I could get out a credit card, but I'm mindful that I'm on video, so... Okay, now get out your card there, get out your card. Now, you should have a card which is the same dimensions as mine, roughly, at least, okay? If you go and measure it, depending on your accuracy, and I know there's slight modifications for each one, What do you get as the dimensions of your credit card? You've got a long side and a short side. Come on, give it to me to the nearest millimeter. What are you getting? 5.3. 5.3? 8.6. Good. Now, yours might be 5.4 or 8.5, or you get the idea. Guess what? This is within a millimeter of the golden ratio. That's really weird. Dramatic sound for the golden ratio. Okay, well, anyway. You get my point, right? That even in seemingly innocuous places, the places you would least expect, okay, you find the golden ratio, and we're not even getting started. Now, there are other places this appears. Before we move on, let me give you a picture for this, what we're about to do, okay? If you haven't had me as a teacher for very long, so you may not have discovered this, but I'm really into metaphors and analogies, okay? So remember I said we're thinking deeply about a simple thing here, okay? One of the best ways to do that is to think about these guys. This is a diamond, right? Again, a quintessentially beautiful object, right? Everyone recognizes this. It's not just that they're rare. People look at them and they're like, wow. Now, unfortunately, and I looked actually for this and I couldn't find a good example. One of the things that makes diamonds so beautiful is that when a really good jeweler gets a hold of one, right? And doesn't just have like one in the rough, actually cuts it and crafts it and that kind of thing. You get this kind of geometry in here. Right? Now the geometry is very, very interesting because if you look at it, right, you can see all the lights and colors coming out of it, right? But the astonishing thing is, and you know, most of us probably will not ever get to do this, or maybe when you're a lot older and you've got enough money to do this, if you can get a hold of a diamond, and they're tiny things, right? And just move it a little bit in your hand, right? And look at it from slightly different angles. All these colors here, they all change completely, right? You see a whole new beauty to the figure, okay? Just by looking at a different angle, okay? So what we're gonna do is, we investigated this golden ratio business from one angle, right? Namely this geometric angle, okay? We're gonna see it from a couple of different ways to try and appreciate what's beautiful about it, okay? So, you got your rectangle there. Let's roll this off, okay? And, I mean, I might leave the picture there, actually. And I want you to make this little dot point. Algebraic definition. Now this sounds very pedestrian, right? Sounds very pedestrian. Algebraic definition sounds as formal as it gets, right? But we're going to try and understand, well, this phi golden ratio business, right? It doesn't just come from rectangles, right? It comes up all other kinds of places. What's special about it? Have a look at how we constructed this thing. Okay? Have a look at how we constructed it. You've already worked out that this length down here is 1 plus root 5 on 2. Okay, can you tell me, what's this distance equal to? We made a new rectangle that was bigger, but we also made a new rectangle that was smaller, right? What is this length? Yeah.
Root 5 over 2 minus 1.
Okay, good. You can see that if that distance is there, I can take away this distance, which we already said was a half, right? So you're getting this. Okay. Now, part of what makes this beautiful, right, is that when you divided this side by this side, this big one by this one, you got that 1.618 number, right? Well, now have a look at this rectangle in here and look carefully at your one, the one you've constructed. Is there not something familiar about it? Let me help you to see it, okay? You've got a calculator, right? And so what I'm going to do is I'm going to say, hold on, this rectangle in here, right? What would happen if I worked out its ratios? Long side divided by short side, here. And I've got, now this is the long side. This is the long side and this is the short side, right? So to work out the ratios in this rectangle, I would say 1 over this one, right? I'm going big divided by small, big divided by small. Can you see what I'm doing? Okay. All right, well, I'm dividing by a fraction, right? So that's 2 over root 5 minus 1, yes? Now hold on a second. You could reach for your calculator here, and you will in a second. But you don't need to. You know what to do with this. We can do something with this, right? If I said to you, simplify this, 2 over root 5 minus 1, we don't, you know, as mathematicians, we don't like fractions like this because the denominator is, what is it? It's irrational, right? It's got a cert in there. So what do we do to denominators like that? We rationalize them. How do we rationalize denominators? How am I going to get rid of this? Yeah, good. I'm going to multiply by, and it has a name, the thing I'm multiplying by. Starts with a C, does anyone know it? The conjugate, good. It's this, right? It's the denominator, but you switched the minus for a plus, right? That word, if you didn't know already, is super important, right? You should get that down. It's called the conjugate. Now, what happens? What happens when you do this? Okay, well, on the numerator, nothing much particularly interesting happens. You get this. Just for the sake of it, I'm going to write the 5 over there. Okay. But on the denominator, and here's the whole trick behind rationalizing the denominator, right? On the denominator, something cool happens. We're taking advantage of a trick, namely difference of squares, right? You've got a minus b and a plus b here. So that's why this is ringing bells. Okay, what happens to the denominator? It's just going to be a squared minus b squared, right? 5, that's a squared, minus 1, which we can work out. That's 4. That's 4. Oh, but 4, there's I can cancel stuff here, right? If that's 2 over 4, 2 over 4, that's just 1 over 2, right? Hold on a second.
No.
It's the same thing.
I know what this is.
No.
That's 5.
No.
That's 5. What just happened, okay? What you did,
I'm gonna die today.
that simple construction with your compass and your ruler, okay? You created 2 rectangles, and the magic of it is that they're similar to each other. Just like that, in one move, you created this rectangle similar to the bigger one. Okay. That's kind of cool.